Contrapositive. This is just an important concept. Well, so we have P implies Q. Now that's kind of like one of our basic logical connectors. There's some other related statements. There's what's called the converse, which is when you just flip. You say Q implies P. Okay, and so again, think about the example we had. We had, if I go to Mars, then I am greeted by little green aliens. You could switch it around and say, if I'm greeted by little green aliens, then I go to Mars. Notice that's not the same statement. It doesn't have the same truth value necessarily. It's not equivalent to P implies Q. Maybe it's true that every time I go to Mars, I'm greeted by little green aliens, but if I'm greeted by little green aliens, it doesn't mean I'm necessarily on Mars. Maybe I went to Saturn and I'm also greeted by little green aliens or something, right? So so they're not the same thing, and that's an important thing, not to swap your if. Basically, you're swapping the if and the then, and it's not it doesn't preserve truth value necessarily, right? So that's the first thing. So the converse is just flip, yeah. Q implies P. The contrapositive, though, is interesting. And again, with the example, I think, let's look at this example again, right? We said, if I go to Mars, or if I, maybe I'll just say it a little bit differently. If I am on Mars, then I'm greeted by little green aliens. Little green aliens. What if I'm in a situation where I'm not being greeted by little green aliens? What can you tell me? Assuming this is true. What if I look around and there's no little green aliens greeting me? What can I say? What do I know is true?
Assuming that the first statement's true, you know you're not on Mars.
Yes, assuming this is true, then if I'm not greeted by little green aliens, then what?
Then like you're not on Mars.
Then you're not on Mars, right? Right, exactly. Like, then I must not be on Mars, because if I was on Mars, I would definitely be being greeted by little green aliens. So if I'm not being greeted by little green aliens, then I must not be on Mars. Yes, good, thank you. So right, so if so again, this was, let me just put this schematically, this was P, and this was Q. So if I am not being greeted by little green aliens is now the strange, it just sounds strange putting out of my mouth. If I'm not being greeted by little green aliens, then I must not be on Mars. Remember, if I am being greeted by little green aliens, that doesn't force it to mean I'm on Mars. They could have come to me on Earth. I could be on Saturn. But let's think about what this is. This statement right here is not Q, and this statement right here is not P, right? So in fact, yeah, the contrapositive of PM, this is called the contrapositive, basically negating the second thing and putting it first, or negating both and switching, I guess, negating both and switching, right? Switching the if and the then. Yeah, this is called the contrapositive. Call it the contrapositive. And so if we have P implies Q, the contrapositive is not Q implies not P. And they are logically equivalent. They're the same thing. In fact, you could check the truth tables, right? These are logically equivalent. The converse was not, but the contrapositive is. And just as a quick check, again, let's write, I don't really need to make these so fancy. Let's just write these down to remember, and then let's write not Q, not P, and not Q implies not P to see that we get the same thing. Right, so true, true, false, false, true, false, true, false. Sorry, I let you get ahead of me, but we're gonna be out of time in like 3 minutes, so I just wanna. So we said this truth table was true, false, true, true for P implies Q. So if I negate Q and I negate P, and now I do the implication, the only one that's bad is when true implies false, right? True implies false is the only way you get false. But if you negate both, you get the same thing. You get true implies, well, yeah, it's in the same location, I guess is my point, right? It's both in the second, they're both in the second row. So false implies false is true, true implies false is false, false implies true is true, and true implies true is true. And so these are the same. So you can sort of prove that they're the same. And in fact, we could write, let me just say this as one last thing, because I think it does come up on the problem set briefly. We could write P implies Q, not Q implies not P. And we can actually put, there's another symbol we could put in between, which is a double-headed double arrow. And this is the logically equivalent symbol, which is basically means they have the same truth table. Okay, that makes sense. I mean, it also means like A, I'm just using A and B to use different letters. Like we say A if and only if. Again, just some language things. We say A if and only if, B. Actually, a lot of times we write IFF for if and only if. And there's even a truth table for that. Like it's sort of like basically it's basically if they're both true or they're both false, which I don't think we've seen this truth table, true, false, false. I'm sorry, wait, I did the same. I read the same column twice in my haste. True, false, true, false. So that is the truth table for that, because they're basically, if they agree, it's true if they agree. So the question or just an adjustment to the, okay. Yeah, and so it also means basically you could also, this also boils down to A implies B and B implies A. Right. So, okay. So that's logical equivalence. But really, if you end up with two columns the same in the truth table, then that you can tell the two things are logically equivalent, like up here. All right. Oh my God, I'm going over time.